Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we will look into Leetcode problem number 118, which is Pascal's triangle. So this is the statement of the problem. Given an integer num rows, return the first num rows of Pascal triangle. So in the Pascal's triangle, each number is the sum of the two numbers directly above it as shown in this particular diagram. So here they have clearly shown how each number is calculated, and they have given few examples, and if you see the constraints, the num rows will range between 1 and 30. Okay, with that, let us switch to our editor and try to understand this problem in detail. So now if you see, they have normally they will give the row number basically, and we will have to generate so many rows which satisfies the Pascal's triangle rules. There are basically few rules. So now if you see this particular triangle, now if you see at the initial and at the end, there are ones. So this is our first row, this is our second row, third row, and so on. So now if you see how we calculate, so for this number, you ignore first row and second row for now. So now if you take this third row, how do we compute this value? Basically, first and the last value will be 1 1 only, but the in between values, how do we calculate? Basically, it will be sum of this value and this value. So 1 plus 1. So now what I will do, I will fill it with 1 plus 1, which is okay. Now we will move to next row, this one. So now this value will be sum of this value plus this value, okay, which is 3. So I will fill 3. Now the value of this cell is again sum of this value and this value, which is 3. So I will fill that. Okay. Now if you go to the next row, this value is sum of this plus this. So it means it is 3 plus 1, which is 4. Okay. Now this value is sum of this plus this, which is 6. Again, for the next value, it is sum of 3 and 1. So it will be 4. Okay. So and so on. You can compute the remaining rows. So it depends on the row number what will come as the input. Based on that, we will have to generate so many rows which formulates this particular Pascal triangle. So this is basically the understanding of what this Pascal's triangle is. Now we have already seen the constraints. Okay, now what you can do, you can pause the video, you can think for possible solution, and if you don't get any solution, you can come back and you can continue watching this video. With that, now basically in this video, this video is going to be a little bit longer one, because we are going to discuss multiple intuitions or multiple optimal methods to solve this particular problem. So the timestamps will be clearly given, so you can go to any implementation and you can watch the particular implementation. So with that, now let us try to understand the first optimal solution. So this video, I'll first discuss one optimal solution first, and then I will discuss the other one in detail, brute better best, because this is not very intuitive. The first method, it's a direct DP way. So you can simply observe and you can try to implement this particular solution. So with that, now let us try to understand this first way. So basically it is a visual path intuition method. So it is a very beginner friendly intuition. So now assume you have this particular value. From here you can go towards left on the down and or towards right on the down. Okay, so this is how you can travel from any number below. So how many paths lead to me? Every number will count how many paths lead to me. Basically, now if you check this particular number, from here you can only come to this number in one way. So that one represents this particular number. Now if you see in how many ways we can come from this to this, start to this point, basically only one way, because from any number we can only travel towards left down or towards right down, not something like from here to here, because we can only travel from here to here and here. So this is how we need to travel. Now if you see, if I stand at 2, how many ways I can travel to 2? One is via this path and another one is via this path. So there are basically two ways to reach this particular cell. So that's why the value represents 2. So this is basically how many paths leads to me. So if you look into different numbers, again to reach here, one path you can take is this, another one is this, and another one is this. So basically 3 paths to reach this particular 3, and for the remaining numbers you can check that. I mean, you can simply draw this flow and you can check for the remaining numbers. So this is the basic intuition. So if that is the case, this formulates our Pascal triangle. Okay, so this is the most beginner friendly intuition. So if that is the case, now how to implement this particular Pascal triangle? So now what I will do, I will rewrite this Pascal triangle in a slight different way. So this is how, I mean, we represent the triangle programmatically. So now if you see, if I want this number, it is sum of this number plus this number. So if I sum up these two numbers, it will give me this number. You can ignore first number and last number always. Now if you want this number, this is sum of this number plus this number. Why? Because this number can be reached in so many ways. This can be reached in so many ways. And to reach me, it is sum of this, because I can reach from here and I can reach from here. So sum of this and this. So this is the simple intuition behind this particular problem. So if that is the case, now how will I solve this problem? So basically what I will do, I will consider initially a row. So basically for row 0, I don't do anything. So this is basically our row 0. So normally they will give row number. So you will have to subtract that by 1 so that you will solve this problem in zero based indexing. So when it is row 0, it is simply one value. So now what I will do, I will take, this is my main result array. So I will simply, when it is row 0, it is only one number. So 0 plus 1, and I will generate and I will put all the values as 1. So only one number, I will push that here. Okay. Next one is our row 1. So basically this particular row. So if it is row 1, now what I will do, I will generate an array with two values, basically 1 plus 1. So 1 comma 1, and fill it with 1 and 1. Okay. So that's how I do. Now there is no modification in this particular value. So I will simply put this in our result array. Okay. Next, now it is row 2. So how will I solve it now? So now it is row 2. So there should be 3 values. So I will first generate the array with 3 ones. Now what I need to do, I need to get this value and put it here. So how will I do that? So I will basically refer this previous array. So basically this value plus this value give us this value. So I'll simply update that with 1 plus 1, which is 2. So now once this is done, I will push this to the result array. Okay. Next one is row 3. So if it is row 3, 3 plus 1. So basically 4 values, and fill it with ones. So this is how I first generate. Then what I will do, I will have to ignore first value and last value, but I will have to consider in between values. So for that, what I will do, I will start from the first index and I will iterate until one value lesser than 3. So basically, if you consider 0, 1, 2, 3, so I'll start from first and I will iterate over one value less than this particular 3. That's how I iterate and get the values. So now I will, for this value, I will refer this and this, I will sum it up and I will replace. Then for the next value, I will refer this value and this value and I will update this with. So this is how I generate this value. Then I will push this value into our results array. So similarly, I will do it for row 4. So since it is row 4, I will generate an array of 5 values and initially fill it with ones. Now for this value, I will add up these two values from the result array. So basically it will give us 4, correct, right? So I will change this with 4. Then for this value, it will be this value plus this value, which is 6. So I will replace this with 6. Next, for this value, I will refer this and this. I will sum it up. So it gives us 4. So I will replace this with 4. So my array would be 1, 4, 6, 4, 1. Okay. So finally, I will return my array. So let us look this in action. So let us take a list of list integer. This we use to store our result. Okay, equal to new array list. After this, now what we will do, we will use for loop for int row equal to 0, row less than our num rows, then row plus plus. Now what we need to generate the entire row, right? So for that, what we will do, we will take a list of integer. So I should be capital. So this is our new array or new row. So equal to new array list. Okay. So this is to store the generated row. Now after this, we will use another for loop. Now this for loop is to generate the columns. So I will say int column equal to 0, col less than or equal to row. Why? Because each row contains the exact number of columns. If it is first row, then it will contain one column. If it is second row, it will contain two columns, something like that. So column less than or equal to row, then column plus plus. Okay. Now what we need to do, first we need to insert one at the beginning and at the end, correct, right? For that I will check if my column, if it is equivalent to 0, if it is the first column, or if my row equal to column, which is the last value. So row equal to column. Then what I want to do, I want to insert 1 to it. So add 1. Okay. If that is not the case, then I will use the else part. So if that is not the case, the in between values, what I will do, it will be new row dot add. So basically I'm trying to add the value. Now what I need to do, I need to take its above value and its left side value. If that is the case, I will have to refer my result list. So result list dot get of first row minus 1, then dot get of column minus 1. So this is the diagonally top element. Then for that, what I will add the element above it. So which will be, I'll copy paste and this will be the same column. So this gives us the value. Okay, after that I will add semicolon. So this basically adds the value into the new row directly. Now after the end of the for loop, so now what we need to do, we need to add this new row to the triangle array, which is result array. So I will say new row. Okay, with this finally what I will do, I will return my result. So this is my result. So with that, hopefully there are no spelling mistakes. So let me try to run this. So it got accepted. I will submit this. So this got submitted successfully. So if you get this question in interview, maybe you should consider approach 2 because it is more intuitive compared to the first approach. The first approach is very straightforward. It will simply compare the previous values and it will sum up and it will give the value. But here comes the actual intuition behind this particular problem. So now if you see, this approach is called team picking approach basically. So it uses combinations. Now if row n is about choosing people from a group of n people, okay, so assume there are n people in that particular row and you need to pick people, say for example in combination, if you want to pick no one, and if you want to pick one, or if you want to pick two, if you want to pick three, then how do you pick? So that is what this problem states. So if you see, if we have four people in that particular row, so we can either pick none, we can pick one, or we can pick two people at a time, we can pick three people at a time, we can pick four people at a time. So if that is the case, so let us say we are choosing r people from n number of people. Okay, so if that is the case, what you can do, assume you are picking any one specific person, so we can either include that person. So basically I'm considering myself here. So what we can do, we can either pick Mahesh or you can exclude Mahesh from picking. Okay, so if you pick Mahesh, then you choose r minus 1 more from the remaining n minus 1 people. Okay, but if you exclude Mahesh, you will still need to choose r people, but from the remaining n minus 1 people. So this gives us basically combination of n comma r will give us basically this plus this, correct, right? So that is what I am writing here. So this is basically our Pascal's rule. So this is what the Pascal rule states. So why the edges are 1? Because if you see, always in the example the edges are ones, right? So why? Because you can choose nobody is one way. So if you don't want to choose anyone, that is one way it is possible. If you want to choose all the people from the available people, then only one way you can choose all the people. So that's why our edges are ones. That's why our edges are ones. So this is the basic funda or basic intuition behind this particular Pascal triangle. Okay, so with that, now let us try to understand how to calculate this particular value. Assume the start and the end values, edges are 1 only, but if we want to compute any in between value, then it is basically the combination, or you can consider any cell. So you can calculate that value by using combination formula. So now what is the combination formula that we know? Basically we know about NCR formula, right? So this is basically n factorial divided by r factorial into n minus r factorial. So this is the basic mathematics which we know. So if you don't know, you can simply remember this formula. So this is the way we calculate NCR. Now if you see here, we have let us consider this number. How do we calculate? So now if you see, the row number is 2, correct, right? Actually it is 3, but we are considering 0 based rows. So now if you see, its column number, which is 1. So it means, now if you see, row number is 2. So basically this is the row number C, and column number is 1. So what is the value of 2C1? It is 2 into 1 divided by R is 1. So 1 factorial is 1. So n minus R is 2 minus 1 factorial. So again it is 1 factorial. So we will get it as 2. Now assume this value. Basically this is our fourth row and second column. So if that is the case, it will be 4C2. So it will be 4 into 3 into 2 into 1. So this is our 4 factorial. Then 2 factorial is 2 into 1 into 4 minus 2. So basically that is 2. Again 2 factorial is 2 into 1. Now if you do, this gets cancelled and this becomes 6. So that is what we got, right? So each cell represents basically the combination NCR ways. So what exactly it means? So if there are 4 people and if we have to pick up 2 people at a time, then how many ways are possible? Assume 1, 2, 3 and 4 are the people basically, and we will have to pick 2 at a time. So I can pick 1 comma 2, correct, right? Then I can pick 1 comma 3, then I can pick 1 comma 4, correct, right? Then 2 comma 3, 2 comma 4, then 3 comma 4. These are the different possible ways. There are 6 ways, right? So this is what it represents, this number. So this is the simple intuition. So if you remember this intuition, then any cell will represent our this particular formula. So this you can easily use. With that, now let us look into the brute force, how we will find this particular triangle.
So let us use two for loops basically. So I will do it here. Now we need our result array. So let it be an empty array initially. Okay. Then what I will do, I will use a for loop for I equal to 0, or what we will do, we will say row equal to 0, row less than row number, then row plus plus. Okay. This is our first loop basically to generate each row. Now what I will do, I will take a empty array which is a row array. Basically I will say it is row array equal to empty array. Okay. Now after this, now I will iterate over each column value. So for column equal to 0, now column is less than or equal to our row, because number of columns is equivalent to the row number basically. So column plus plus. Now what I will do, so now our row array of column. So we need to fill each column, right? It will be equal to, we will have to apply this NCR formula, correct, right? So for that, what I will do, I will say combination. So basically this is a method which takes n value comma r value. So for us, n is nothing but our row here, then r is nothing but our column. So I will pass those. Then what I will do, finally I will push, or I will add this particular row array to our result. So push of row array. So this is basically the generated row, and finally what we will do, we will return our result array, which is the Pascal array. But how do we find this, or how do we write this combination method? So we knew NCR equal to n factorial divided by n factorial, r factorial into n minus r factorial, correct, right? So I will use that. So first we need a method factorial. So I will write a method factorial. It will take the value n. Okay. So then factorial equal to 1 initially, then while n is greater than 1, what it will do? Factorial equal to factorial into n. Okay, then after this I will decrement the value of n. Okay, so this way we will get the factorial. You can check the basic condition and all those things. If the value is 0, all those things which we will see in the code. And then we need another method, which is our this combination method. So I'll write that here. So basically this is our combination. So it will take value n and r, correct, right? So it should be something like this. So I will say it will be return factorial n, okay, divided by, again we will use factorial r, then again one more divided by, we will say factorial n minus r. So this way it will give us the combination, correct, right? So this is the very extreme naive way. So here what happens normally, it will find n factorial, it will find r factorial, it will find n minus r factorial, correct, right? So is it an efficient way? No, right? So this is not very efficient. So one more thing what we can do is, so what I will do, I will simply remove these things. So assume if we have 4C2, okay, then how we can compute it? One way would be the standard 4 into 3 into 2 into 1 divided by 2 factorial, which is 2 into 1, then 4 minus 2 factorial is 2 factorial, again 2 into 1. This is one way. Another one simple way would be, so 4 into 3, basically 2 values only. So 4 into 3 divided by 2 into 1, which is same as this entire equation. So now this will also give the same thing for us, which is 6. This will also give us 6. It is same, right? So now if you see, unnecessarily we are calculating the factorial of this number, again factorial of this number, again factorial of this number. So we can avoid that. So we can avoid that. So here we know the value of n, we know the value of r. So simply iterate from 1 to the value of r. So basically if you see, we can simply rewrite it as 4 into 3 divided by 1 into 2. So from 1 to 2 you iterate. First you don't remove anything. Second time you remove 4 minus this value minus 1, basically. So that's how, I mean, you can easily improvise this particular formula. This is a better way. So now if you see the time complexity, so let us first consider the brute force. Okay, for brute force it is n square for generating all the Pascal array, and at each point again we end up calculating the factorial, right? For each number it is almost n. So it is of order n square into n, which is nothing but order n cube. Okay, this is for the brute force. And what is the space complexity? If you see the space complexity, we don't use anything extra apart from the array which we store, right? So with that, what we can say, it is only of order n square for that particular array, Pascal array. Now, if we improvise this one a bit, then the better solution, basically using this particular way, it gets reduced to O of n square. And we don't use anything extra apart from the O of n square space for storing the values. That's where we can consider either O of n square or even we can consider O of 1, because O of n square is required to store the answer. Okay, so this is for better solution. Further improve it. Maybe yes, let us see how to do that. So now let us try to see how to generate the entire array. So if we have the row number, okay, so basically entire row, I mean, so if we have the row number, let us take this particular example. Now here what we know the row number, correct, right? So we can use this particular formula. Now I will try to expand using whatever the formula I mentioned. So basically it is 4C0, which is 1, correct, right? Any value combined with 0, because 0 combination will give only 1, and 4C4 will give us 1, correct, right? So let us see that later, but first value would be 1 now. Now how do we write 4C1? So 4C1 can be written something like 4 divided by 1. Why? Because we already saw, right? If 4C2, then use this value so many number of times in a decremented value divided by this value factorial 2 into 1. So here the value of r is 1, that's why it is 4 by 1. Okay, next value, let us see, it will be 4 into 3 divided by 2 into 1, correct, right? Now the next value, this one will be 4 into 3 into 2, because the value here is 3, then 3 into 2 into 1. Okay, this is next value. Next 4C4 will be 4 into 3 into 2 into 1 divided by again 4 into 3 into 2 into 1. Okay, now what you can observe, or I'll little bit rewrite this one. So first value I will write as 1 divided by 1. Okay. Next second value I will write 1 divided by 1 into 4 divided by 1. Okay. I will say why I am writing that. Now the third value I will write 4 divided by 1 into 3 divided by 2. This is same, correct, right? If you see, next value what I will write 4 divided by 1 into 3 divided by 2 into the last value which is 2 divided by 3, correct, right? Now the last one 4 divided by 1 into 3 divided by 2 into 2 divided by 3 into 1 divided by 4. This is how I rewrite this entire row. Now one thing what you can observe, this is our first value. So this value is present here, right, in the second value, correct, right? Now if this is our entire second value that is present here, correct, right? I'm ignoring 1 by 1. Maybe you can write 1 by 1 here, correct, right? So this value into something, this previous value into something, this is again previous value into something. Now if you see, this is our previous value into something. Now if you see, this is our previous value, this entire value into something. So what is that something? Let us see. So if initial value is 1, then the next value will be, if you see, this is 4. 4 is basically our row number, and if you see 1, so this is basically our column number, correct, right? So this is row number and this is column number. Next we will see, this is our previous value. So this one we have already computed. So now this 3 and 2, how it is related with our row number and column number? So if you see, this is 4 minus 1. So divided by, this is 2. 2 is basically our column. So it is nothing but 4 basically row number minus column minus 1 divided by column, correct, right? This is how, I mean, we can infer from this particular equation. So what I am trying to say, now any value in the row will be something previous value. So something is previous. It starts with 1 we will see that. So into row minus column minus 1 divided by column. So this is how we can derive an equation from this. So we will use this. So we will, using this, what we will do, we will generate the entire row. If we know the row number, we can generate the entire row. Let us write a pseudo code for generating the row. Generate row, correct, right? So it will take the row number, basically row, basically. So now what it will do, let us take previous value. Let us assume our previous value is 1, okay, and our entire row will be some empty array, okay. So basically I will say it as row array. It will be empty array initially, okay. Now what I will do, I will push this 1 to row array. So simply I will initialize my previous array with value 1. Now what I will do, I will say I equal to 1. I won't start from 0 because already the 0th value we have, which is 1. I equal to 1, I less than row I plus plus, okay. So now our row ARR of I equal to, so our previous value into row minus column is this one only. So I minus 1, so we can also call it as column, divided by I, correct, right? So this will generate one row for me. If I know this is how I generate one row. If I know row number, then how to generate n rows? Basically I will have to call this n times, correct, right? For row equal to 0, row less than row numbers and row plus plus, correct, right? Then what I will do, I will simply call this generate row method here. So this is my result array, which is empty. So I will simply say result dot push or result dot add. Basically this is list of list, we can say in Java, or in JavaScript we can simply consider array. So I will say generate row and simply pass the row number, okay. For all the rows it will generate, and finally you return the result. So this is how we can generate all the rows in the Pascal triangle effectively. So this is this is also again a DP way, because we try to remember the previous value and then try to generate the current value. But this is the most effective and most optimal way. So if you explain this, interviewer will be very happy with your answer. So with that, now if you see what is the time complexity, it is clearly of order O of n square, correct, right? Because for each row you will generate once and you will call that multiple times for n number of times. So time complexity is of order O of space complexity will be of order n square, because we use array to store the Pascal triangle. So apart from that, we don't use anything extra. We can also consider it as O of 1, because this O of n square, we use it to store the values. Anything should be fine here. I mean, you can explain this to the interviewer. With that, maybe what we can do, we can switch to the Leetcode and let us try to execute this.
Now what I will do, I will remove this in between content. Remaining things will keep it. Then I will add a private method. So this will give me list of integers. Okay. So this is to generate the, so basically it will take the row number, right? So I will pass int row to it. Okay. Then Now this method basically it should generate the entire row, right? So for that, what I will do, I will take a variable previous and I will add one to it. Okay. Then after this, what we need list of integer. So basically, this is our new row equal to new array list. Okay. Then after this, now what I will do, I will say for before this, for the new row, what I will do, I will first add the previous value. So I will say new row dot add of 1. So this is the first value in that particular row. Then from column equal to 1, because column 0 we have already processed, we have added 1 here. So I will start from column 1, then column less than or equal to row, then column plus plus. Okay, so now what we do, let us directly add the value to the new row. So add, so we will take the previous value, then we will multiply that with our row minus column minus 1, then divided by our. So this will calculate the current column for us, and I'm directly adding that to our new row. So now after this, I need to update my previous value, right? So previous value should be updated with the current value. So I will say my previous equal to new row dot get of and pass the column number. So this will give us the current value and it will be stored in previous value. So this way we will generate and finally we will return new row from here. So this will generate the entire full row. Okay. So now here we start from 0th row and we try to generate all the rows, right? So now what I will do, I will try to generate row by row and I will try to add it to our result array. So I will simply call my generate row, then I will pass the row. Okay, so this will generate row one after the other and it will add it to the result array. So with that, mostly it is all fine. So I will run it. There is some issue. So yeah, I missed adding the type here. So it should be int call. So with that change, let's rerun. So it got accepted and I will submit it. So it got submitted successfully.
So this is how, we can use the combinatorics formula effectively and also the DP technique to memorize the previous value and to find the entire row, and we can generate one row at a time for the Pascal triangle. Okay, so now there is one more kind of intuition which is worth to understand. So now if you see, this is a binomial expansion intuition basically. So if you consider x plus y raised to n, now what Pascal's triangle gives is the coefficient of expanding x plus y to the power n. So what exactly it means? Let us take a small example. So if the row number is 3, what we got? 1, 3, 3 and 1, right? Now if you see x plus y to the power 3, it is 1x cube, 3x square y, 3xy square and 1y cube. Correct, right? If you see the coefficients of this particular expanded equation, it is 1, 3, 3, 1. Correct, right? So it is because of this particular formula. Okay, so now if you see, this Pascal triangle is really just listing all the binomial coefficients for each power. The triangle is basically a map of all expansions of x plus y to the power n, where n is basically the row number, correct, right? Now if you see x plus y to the power 0, it is simply 1. So this was our first value. X plus y to the power 1 is 1x plus 1y, correct, right? So 1, 1. This is the second row in our Pascal triangle. Now, if you see x plus y to the power 2, it is 1x square plus 2xy plus 1y square, correct, right? 1, 2, 1. You can correlate this with the Pascal triangle. And x plus y to the power 3, 1x cube, 3x square y, 3xy square plus 1y cube, correct, right? 1, 3, 3, 1. So this is one more intuition of, when we correlate this Pascal triangle with the binomial expansion for the x plus y to the power n. So with this explanation, so we understood what are the different intuitions behind this particular problem. So hope this video was interesting, and if that is the case, please consider subscribing to my channel and also like the video, share this with your friends, and also add any comments in the video. If you have understood it well, please add that as well. Thanks for watching the video.